Hey guys, I'm back again. So, some of my juniors have requested me to make this video, and in this video, I've covered how to qualify TSSET 2018 important topics, just the important topics, guys, not the entire syllabus, because as entire syllabus is vast, you should be wise and smart while preparing for the exam, and just prepare only those areas where you can get a definite question. Okay, and I've also covered the weightage of each topic. Coming to inorganic chemistry, in inorganic chemistry the major part is coordination chemistry. You can expect many questions from coordination chemistry only, and the important areas that you have to study from this coordination chemistry are IPAC nomenclature, isomerism in coordination compounds, that is nothing but ionization isomerism or hydrate isomerism or geometrical isomerism, etc., and hybridization of complexes according to VBT, especially with nickel and copper complexes. And there is this very important theory, that is CFT, crystal field theory. In crystal field theory, you have to study this CFSE calculation, crystal field stabilization energy calculation, factors affecting crystal field stabilization energy, and pairing energy, spectrochemical series, lattice energy of main group elements, crystal field splitting in other geometries like trigonal, bipyramidal, square planar, etc. I'll just roll it down. Yeah. And then comes this pi accepting and pi donating ligand sequence, that is the order, and number of microstates, term symbols. You can expect a definite question from this term symbols, guys, so be perfect with term symbols. Selection rules, that is Laporte or spin orbital selection rules, and then John Taylor distortion, which is very important, and electronic spectra of D1 to D9 configurations, okay, and nepheloxitic series, charge transfer spectra, magnetic properties. This charge transfer spectra is also important, guys, and magnetic properties, that is paramagnetic, diamagnetic, or calculation of magnetic moment. And this Irving Williams series is also important, guys. Chelate effect, inert and labile complexes, inner and outer orbital sphere mechanism, steering effect, trans effect. So overall, from coordination chemistry, you can expect 3 to 4 questions definitely from only these areas. Okay, if you prepare only these areas, you can easily attempt 3 to 4 questions, guys. And so coming to this chemical periodicity, you can expect a definite question from chemical periodicity, and the major areas are ionization potential, electronegativity, solubility, acidity, basicity, hydrides, boiling points of nitrogen, oxygen, and halogen family hydrides. So you can expect 1 or 2 questions definitely from chemical periodicity. And there is this very important question you can easily attempt, guys, because this is very easy, that is bond order, calculation of bond order, molecular orbital theory. So there will be a question definitely from molecular orbital theory, and sometimes they might be asking configuration also. So there will be a question, definite question from molecular orbital theory. And then comes this lanthanides, electronic configuration. The major areas are electronic configuration, basicity, magnetic and spectral properties, separation of lanthanides. So lanthanides is very easy, guys, so they might ask 1 or 2 questions from lanthanides also. And here comes the group theory. In group theory, you should be aware of the symmetry, CN, CNV, DN, DND, DNH, and CNH symmetry. Okay, from group theory also you can expect 1 or 2 questions. And metal carbonyls and metal clusters. So from metal carbonyls and metal clusters, you can expect questions from these areas, that is number of metal bonds, 18 electron rule, bond order in metal clusters, identifying close zone edo, etc., for main group clusters and carbonyls, and EAN, that is effective atomic number, and structure of metal carbonyls, Watt's rule for hexanuclear metal carbonyls. So easily you can expect 2 to 3 questions from metal carbonyls and metal clusters. And then there is boranes, structure of boron hydrides, skeletal electron pair calculation or framework electrons. And in boranes also there is Watt's rule and Stike's number. So from boranes also you can expect a definite question. Okay, and I'll just roll it down. Yeah, and in OMC, in OMC these areas are enough, guys, so you don't have to go to any other topic from OMC other than these. Okay, that is, you should just prepare these only these areas, because most of the previous questions are from these areas only. And the important areas are Wacker's process, Wilkinson's catalyst, OXO process, hydroformylation, Monsanto acetic acid process, ferrocene, Zeiss salt, oxidative and reductive eliminations, that is oxidative addition and reductive elimination, and Ziegler-Natta catalyst, that is nothing but polymerization of alkanes. So these are the major areas of OMC, and these are very easy. They'll be asking very easy questions from OMC, so you can easily expect 2 to 3 questions from OMC also. And then there is this bioinorganic. In bioinorganic, the major areas are hemoglobin, hemocyanin, hemerythrin, myoglobin, structure and magnetic properties, metals present in cytochrome C, and other metal enzymes. So these are the important topics in bioinorganic, and you can expect 2 questions from bioinorganic. And these are below are these small topics, guys. All these are small topics. You can just prepare, you can just prepare within 1 hour or 2 hours. So these are very small topics, and there will be a definite question from isolobal. Okay, and there will be a definite question from HSAB, and these two are choice. It's up to you. If you have enough time, you can prepare from for these two also. And there is this miscellaneous topics, guys, miscellaneous topics. So there will be a definite question from green chemistry, drug chemistry, environmental chemistry, and supramolecular chemistry. That is nothing but about synthesis of nanoparticles. Okay, so it's easy to prepare environmental chemistry, and green chemistry is also similar to environmental chemistry. And coming to spectra, if you are aware with basics of spectra, you can attempt 6 questions easily, 6 to 7 questions easily, because they'll be asking only the basic part of spectra. And the important spectra are IR spectra, UV, H1C13, P31, NMR, and Raman spectroscopy. Especially, you should be very good with carbon dioxide spectrum, guys. That is from according to carbon dioxide spectra, according to IR and also Raman, because many questions are from carbon dioxide only. So you should be aware with just this general spectroscopy, basics of general spectroscopy of everything, that is IR, UV, H1C13, P31, and Raman. Coming to physical topics, in physical topics, the most important topic is quantum chemistry, because most of the questions are from quantum chemistry, guys. So I know for most of them quantum chemistry is hard, but they'll be asking just the basics, guys. So just be good with basics of quantum chemistry. And in quantum chemistry, the major areas are operators, commutator operator, linear and non-linear operators, eigenvalue, Laplacian operator, Hamiltonian operator. And this is important, guys. You can expect a definite question from this particle in 1-dimensional, 2-dimensional, 3-dimensional, and degeneracy, and also calculation of energy. So 3 to 4 questions will be from quantum chemistry, guys. And from electrochemistry, I'll just roll it down. From electrochemistry, the major areas are molar conductance, equivalent conductance, Faraday's first law and second law, Kulroch's law and equation, solubility, electrode potential, Nernst equation, finding out this equilibrium constant, that is K, from Nernst equation. That is this is the formula of finding out the equilibrium constant, and finding out this EMF of a cell. They'll be giving this reduction potentials of both the cells, and you should calculate the EMF of a cell. This will be a definite question, guys. And electrochemical series, pH, solubility product. So you can expect a question from this solubility product also. and ionic strength, this is also important. D by Huckel-Onsager equation, this is also important, guys. And coming to thermodynamic part, thermodynamics. In thermodynamics, enthalpy, entropy equations are important, and examples of state and path functions are important. Examples of extrinsic and intrinsic properties are important. Euler's rule, Maxwell's relation, definite question. Internal energy, Gibbs free energy. They'll be asking just the formula directly, guys. That is just the equation directly. Gibbs-Helmholtz equation, Clapeyron equation, Clausius-Clapeyron equation, Gibbs-Duhem equation, Joule-Thomson effect, second law of thermodynamics, and especially there will be many questions on entropy, guys. So you should be very perfect with entropy, any entropy question. And heat capacities, that is Cp and Cv, Carnot cycle, isothermal and adiabatic expansions, and compressions, efficiency of heat engine. So from thermodynamics, you can expect 2 to 3 questions, guys. Coming to atomic structure, in atomic structure, they'll be asking only the basics, guys, and they'll be asking 2 questions from atomic structure. If you want to go through atomic structure, I made a video on atomic structure which covers all the formulas of atomic structure, and I have also covered the previous year's examples of TSSET. Okay, and that is completely enough, guys, for TSSET. You can just go through my previous videos. And there is this chemical kinetics. In chemical kinetics, rate of reaction, first order, second order, and third order, T half, calculation of T half, calculation of rate constant, rate of reaction with respect to temperature, Arrhenius equation, Lindeman's theory, transition state theory, effect of ionic strength on rate of reaction. So from chemical kinetics, you can expect 1 question, guys. In solid state, everything is important, guys, so you have to go through everything. As it is a small topic, they'll be giving from any part of solid state. Okay, so you can expect a question from solid state chemistry. And then there comes adsorption chemistry or surface chemistry. In surface chemistry, the major areas are physisorption, chemisorption, Friedrich adsorption isotherm, Langmuir adsorption isotherm, and Bett adsorption isotherm. You can expect a question from surface chemistry. And from chemical equilibrium, Le Chatelier's principle is important. And from ionic equilibrium, calculation of pH, acid and base indicators, buffer solutions, these are important from ionic equilibrium. And nucleochemistry basics, and colloids, phase rule basics. So all these 4, that is from chemical equilibrium and ionic equilibrium, nuclear chemistry, colloids, and phase rule, you can expect 3 to 4 questions, guys, from all these four topics. Okay, and coming to analytical chemistry, only you just have to prepare only these 2, guys. So in previous years also, they just asked about TGA and DTA only. So just only these topics are completely enough. In organic chemistry, they'll be asking only the basic part, guys. So you should be good with basics of organic chemistry. And firstly, they'll be asking about IPAC nomenclature. There will be a definite question from IPAC nomenclature. That is, they might just ask this general IPAC nomenclature, or from bicyclic compounds or spiro compounds, or heterocyclic nomenclature, or some exceptional nomenclature. So I made a video on IPAC nomenclature also with some TSSET examples in my previous videos. You can just go through it, guys, and there will be a definite questions. That is, there can be 2 questions from IPAC nomenclature. And then there is stereochemistry. They might ask you to assign this RNS configuration and EZ cis trans stereoisomers, that is number of stereoisomers, and number of stereocenters or chiral centers. Okay, you can expect 2 questions from stereochemistry, guys. And then there is this easy topics, that is aromaticity. In aromaticity, Huckel molecular theory, Huckel molecular orbital theory is important, and delocalization energy or resonance energy. And they'll be giving these compounds and ask you to identify whether they are aromatic or anti-aromatic, or homoaromatic or non-aromatic. And you can expect a question from 1 question from aromaticity, guys. I'll just roll it down. Yeah, and then there is conformational analysis, and you can expect a very easy question from conformational analysis, guys. So they'll be asking which of the following is a cis compound or trans compound, or which of the following is a stable one. And it's important to study this Klein-Brillag terminology also. And conformations of cyclohexane is also important, guys. And there will be a question from conformation analysis, one question. Coming to amino acids, and these are the basics of amino acids, that is pH, isoelectric point, essential amino acids, acidic amino acids, basic amino acids, and tests for amino acids. So these are the basics, guys. You can just go through these basics in any intermediate book also, and you can expect one question from amino acids. And then there is this alkylates and terpenoids also, guys. But alkylates and terpenoids is vast. It takes much time to study, so you can just you can just guess questions from alkylates and terpenoids. And then there's heterocyclic compounds. Definitely there will be a question from heterocyclic compounds. So you should just stress on nitrogen containing compounds, guys, whether it is pyridine or quinoline or isoquinoline, any compound which contains nitrogen. So just prepare those compounds, that is heterocyclic compounds. You can expect 2 questions from heterocyclic compounds. And then there is pericyclic compounds. In pericyclic compounds, specially just stress on electrocyclizations, allowed and forbidden conditions, that is thermal and photochemical conditions, con rotation, dis rotation, okay. And these are the important reactions in pericyclic compounds, that is Diels-Alder reaction, Cope rearrangement, Claisen rearrangement. These are the important areas of pericyclic, guys. So they might ask 1 or 2 questions from pericyclic. And then comes polymers. Yeah, and these are basics, guys. So intermediate polymers, they'll be asking basics from intermediate. So if you have intermediate textbook, it's well and good, okay. Basics from intermediate, and they'll be stressing on number average molecular weight, or weight average molecular weight, okay. And there will be a question, that is one question from polymers. And coming to 9th one, that is reactive intermediates. In reactive intermediates, carbene, free radical, nitrene, benzene. Reactions which are undergoing through these reactive intermediates are important, guys. So you can expect 1 question from this. And basic organic chemistry, that is just focus on mostly on substitution reactions and elimination reactions. You can expect a question from basic organic chemistry also, and it is very important, guys. So you should be very good with this coupling reactions, because coupling reactions are very easy, but you should just you should just have an idea of coupling reactions, and you can just attempt these coupling reactions in just 10 seconds. So the basic very important coupling reactions are Suzuki, Stille, Heck, Sonegashira coupling reactions. So just go through these coupling reactions, guys, and you can expect 2 questions from these coupling reactions. 2 questions. Coming to reagents, oxidizing reagents, that is KMnO4, chromium 6 reagents, para-iodate, which is useful in cleavage of 1,2 diols, and there is this epoxidizing agent, that is hydrogen peroxide in basic conditions. You can expect a question from this. And there is this reducing reagents, that is hydroporation. There was a question from this hydroporation in the previous year, that is in 2017. And oxymercuration and demercuration is also important, guys. And coming to electron transfer reductions, in electron transfer reduction, sodium and liquid ammonia is important. Birch reduction, Clemmensen reduction, Wolff-Kishner reduction, Lindlar's catalyst, Wilkinson's reduction, and also hydrogen in palladium and carbon is also important. So from all these reagents, you can expect 1 or 2 questions, guys, okay, or you can expect 2 or 3 also from all these 3, that is oxidizing, reducing, and electron transfer reductions. And coming to organometallic compounds, in organometallic compounds, Grignard reagent is important, organolithium reagents is important, organoboron reagents is important, and also organophosphorus reagents are important, that is Wittig reaction, very important, guys. And you can expect a question from organometallic compounds. And then there is this name reactions and rearrangement, and completely these reactions are completely enough, guys. So you don't have to go to any other name reactions also. These are completely enough for TSSET, okay. So the named reactions are Friedel-Crafts alkylation and acylation, Riemann-Tiemann reaction, aldol condensation, pinocol-pinocol rearrangement, Wagner-Merwin rearrangement, Favorsky rearrangement, and quasi-Favorsky rearrangement, guys, and benzylic acid, benzylic acid rearrangement, semi-benzylic acid rearrangement. And then there comes Hoffman, Curtius, Smith, and Lawson reactions. These are very important, guys. You can expect a question from all these four. And Beckmann and abnormal Beckmann, this is also important. And benzoin condensation. From all these 10 name reactions, you can definitely, definitely score almost. You can expect some 3 to 4 questions from only these 10 name reactions, guys. And if you're good with all these 10, you can go through these reactions, guys. That is Baeyer-Villiger oxidation or Michael addition or Manage reaction, Somlet-Hauser rearrangement, and Baylis-Hillman reaction. So if you are good with all these 10, and if you have time, you can go through these reactions also, guys. Okay, so these are the organic topics. And as I have given you this weightage also, that is 3 and 4, that is 3 or 4 questions will be coming from named reactions and rearrangements. So that's it, guys. That's it in this video. And I just want to tell you that I have given this weightage also. You can prepare for this exam according to the weightage. Okay, and lastly, all the best, guys. Keep going, keep practicing, and keep encouraging. Thank you for watching this video.